Hello students, this is Basavaraj Sir, your biology master teacher. Welcome to Vedantu NEET English students. So quickly let me know in the chat if I am audible and visible to all of you. Yes? Quickly let me know in the chat. Hello Shri, hello Pavitra, hello Divya, hello Chinnu. Yes? Now students, you might be thinking, why is Basavaraj Sir late? Right. Was there a reason for Basavaraj Sir being late? There is one reason. No. There are two main reasons. There are two main reasons because I am late right now. Let me invite the reasons which I am late. Sir, ma'am.
We are like those worms. The two worms.
Who made everything
God. Sir is black. Oops. Why such a racist comment, bro?
Sir, it is back. Sir.
Oh, sir is back. Oh. I thought the studio lighting was so bad. Sir is black.
I'm still trying to find where is the comment. Hello.
Oh God.
Oh man. Seriously.
That was epic.
We know, like, we look
Yeah.
a little.
Yeah.
Since we are actually very glowing and
Yeah,
very
well,
fair and
Very.
this color we are actually, but then in the studio we are little.
Sir, this is chemistry topic, sir.
No. This is yes, chemistry itself.
Oh.
Desha ma'am topic I'm taking today.
This is next level stuff. Hello guys.
Hello.
Okay, so basically, Basva sir is going to kill it today in the RNA batch, and all the regular students, you have to show your josh, you have to show your enthusiasm in the chat box, because you are a part of the best YouTube series, and that too we are so regular, and we are doing all the topics in so much of depth and detail. So always show that josh, and most important thing is you have to call your friends. I know you'll be like, sir, why should I call, sir? But understand, sharing is caring, plus you are going to become the best doctors. You want your friends to be along with you in the same hostel party.
Exactly. So ma'am,
Yes.
few words for the students before I start the class.
Good afternoon, good evening, good evening students. Students, whatever I taught in the morning, no, sir is going to teach a little detail about it, okay?
Yo, why? You didn't teach in detail.
Appadi alla. What is this?
Like backbone chapter,
okay.
backbone chapter for the chapter.
Yeah, exactly.
Technically, this was supposed to be before and that chapter was to be afterwards, but
okay.
mix and match, it's fine.
No problem.
Yeah.
See, so much of fire. Where does this fire go when all of us are teaching like separately?
No, they want us to see together as a team. Students, we are a team here. The only
Then we'll do one thing, we'll split the board into 3 pieces. I'll start teaching her, you teach her.
Desha ma'am will be teaching in Punjab.
Next level marathon. That will be. But yeah, guys, I think we should will come together very often, and a lot of exciting things being planned for all of you, definitely.
Yes.
And Basva sir is looking like Ryan
Parag.
Who is Ryan? I
that
had
is a
heard of
cricket
Pan Parag. Who is this Ryan?
Sir really has something. Okay.
Some issues there.
Some issues there. Some underlying issues there. Can you see that?
God.
First black comment came, now Pan Parag.
Parag is coming next. Will be something else.
Students,
Sir, he's
this
a cricket player.
This
cricket
is
player.
serious.
Okay.
It doesn't matter at this point.
Yeah.
Anything we will make it into our own language.
Our own language,
We have now
exactly.
cumin, jeera.
Humans. So students, this is just an introduction to all of us, and we wanted you to see us as a team, right? How we always are. This is how we always are.
Yeah,
we are always laughing. We are making each other jokes.
Actually, you will be like that in front of the kids also. But kids, no, they don't chat properly.
Yeah.
They don't tell any story what is happening in their life in their
So
comments.
they forget to even laugh. When I crack joke, no, I only laugh by myself. Now
Yeah,
I'm
they
like,
forget to laugh.
Yeah.
Students, today all of you give us hearts, right? Today we have a magic wand introduced by Gopika ma'am that we are going to give you back hearts.
Oh my god!
That is a new technology we have.
Yeah, we are also missing Diksha ma'am. This
Yes.
is for Diksha ma'am. She'll
No.
soon come and
We
join.
will Photoshop
Diksha ma'am
her.
is making shots now for all of you.
Yeah, even we love to see all of you together, but you
Yeah.
people don't come together. You come single, and then you
Exactly.
expect us to be like this together all the
See
time.
how much fun it is for you guys when all of us are together. So we too will have a lot of fun when you bring your friends.
Exactly.
And, you are there in the chat box. You are telling us your stories. You are asking your doubts. You are answering. No, sir, this is correct. That is correct. So we will also have fun.
Exactly. So,
So-
yes.
Okay. So Basva sir, all the best, sir.
Thank you so
Continue.
much. Thank you
Do
so much.
well. Okay, do well, Pansara.
So
Do well.
much
All the
of
best. Pan Parag.
peer pressure now. Like you see, do well.
Black hearts.
Black hearts. Black hearts.
panpara color is green and red.
Green and
also.
red.
Red, green, red.
No, but then it's made up of leaf, na?
Leaf, bitter leaf, so
So it will become red.
red.
After chewing. So they are putting green
And red.
Don't
They are
like-
not thinking so much, please. No one is thinking so much.
But I'm trying to
She's
inculcate
trying
that thought.
to. She's
Try
trying
to
to.
involve biology somehow, but botany somehow no.
No, I'm basically showing them
Oh, yeah.
that the heart is not for you. That is what I'm trying to prove. I hope it was
Oh,
clear.
really? Okay.
Okay guys, bye bye, take care, and Basva sir will continue. All the best.
Thank you so
Maintain
much.
this energy. Okay.
And
Exactly.
students, do not forget to smash the like button
Yeah.
on tomorrow's video as well, because part 2 of these 2 chapters will be coming tomorrow.
Exactly.
Okay? If no likes, then no Gopika ma'am.
Yay. Okay, bye bye.
Bye bye. Thank you so much, sir. Thank you so much, ma'am. See you tomorrow. So, students, that was just the basic introduction which we had. So, we'll be doing the chapter biomolecules. So, all of you know this chapter is around. This chapter, let's see, usually it's around 6 to 7 questions. 6 to 7 questions usually come from this chapter. 6 to 7 questions. Now, if you want to master all the 6 to 7 questions, you need to watch the entire lecture. Like, there is no particular rule that, only from this part of the chapter you'll get more questions. There's no rule like that. You can get questions from carbohydrates, you can get questions from proteins, you can get a question from enzymes, you can get a question from any single part of the chapter. So the entire chapter as a whole, is extremely important. And today is the class where we completely decode the chapter and we make it such a fun chapter. And after today's class, you'll be like, biomolecules, biomolecules. It is one of the easiest chapters which you will come across. One of the easiest chapters. So let me know in the chat if we can start the most amazing chapter, the backbone chapter, the same chapter which you will be studying in your MBBS first year, that is biochemistry. So let me know in the chat if we can start it. Yes? Now this is part wise, we are doing part wise. Today is part 1, tomorrow is part 2. Alright? So let's start with the biomolecules. So let me know in the chat quickly, first of all, what is the meaning of biomolecules? Biomolecules is nothing but the molecules. They are the molecules found in the living cells. They are found in the living cells. Found in the living cells. Yes, they are found in living cells. That is your biomolecules. Now quickly, let's give me some examples of biomolecules. All of you would have known about proteins, lipids, carbohydrates. All of these are different types of biomolecules which make up the entire body, which makes up our entire body. Now let's do a simple story. Yes. So all of you know this is our earth. Let me draw the earth. Yes, this is our earth. Now we have earth's crust here on top. We have earth's crust on top. Earth's crust is there on top. Okay. Now students, on this earth's crust, on top of this earth's crust, there are certain elements. On this earth's crust, on this top of this earth's crust, there are certain elements. The elements such as your hydrogen, oxygen and carbon. Hydrogen, oxygen, carbon. But there's very something interesting. The something interesting part is that the same elements can also be found in the living cells. Yes. The same hydrogen, the same oxygen and the same carbon can also be found in the living cells. Now one question arises. If the same elements are present in the living cells and also on the earth's crust, what is the difference then? What is the difference? The difference is very simple. The elements which you find in your earth's crust and the living cells, the major difference is going to be the abundance or the concentration or the amount. For example, the hydrogen, oxygen, carbon is present in higher quantity in the living cells. It is present in a higher quantity or higher amount. The same elements are found in a much more lower quantity when it comes to earth's crust. That what differentiates living and non-living. The amount or the concentration of the different elements. Is that point clear to you? Tell me in the chat. Red dots in the chat if the point is clear to all of you. Simple point, right? Simple biology. The chapter is very simple. Now students, I told you on the earth's crust. On the earth's crust there is hydrogen, oxygen as well as your carbon. Now some of you will be like, sir, I do not believe you. Some of you will be like, no sir, I don't believe you. Give me an experimental proof. So can we do some experiment now? Tell me, can we do some experiment? Ready for experiment? Now I want all of you to become a scientist now. I want everyone to become a scientist and do a simple experiment. Simple experiment. The experiment goes like, we take a liver piece, a chicken liver, okay? We have a chicken liver here, or you can take a normal leaf also, or you can take a normal leaf. You can take a normal leaf also, okay? Now, this is a leaf. Liver or a leaf. To this liver or a leaf, you need to add it into a mortar and pestle. Okay, this is your mortar. Mortar is here. This is pestle. You add this leaf into the mortar and pestle. Okay, done. It is added. Now to this mortar and pestle, you add some liquid, a solvent. The solvent is called as trichloroacetic acid. You add a solvent called as trichloroacetic acid. Trichloroacetic acid. Okay, trichloroacetic acid, that is Cl3COOH, trichloroacetic acid. Formula also is very important. Formula also is very, very important. Okay. So students, formula also is very important. Trichloroacetic acid. Okay. Once trichloroacetic acid added to it, you will get one chutney now. Okay, you will get one nice chutney. You will get here. Nice chutney. Let's call this chutney as slurry. Let's call it as slurry. Okay, we have a slurry formation here. We have a slurry formation here. Now the next thing you need to do is take this slurry and add it to a beaker. You need to add it to a beaker. Okay, let me segregate it. You need to take the slurry and you add it into a nice beaker here. Okay, one beaker is here. Okay, let's take a beaker here. To this beaker, on top of it, here we have a separate cloth. On top of this beaker, we have a separate cloth here called as muslin cloth or cheesecloth. We have a muslin cloth or cheesecloth. What do we call it? Muslin cloth or cheesecloth. Now on top of it, we are adding the slurry. We are adding the slurry. Okay, the slurry is here. Slurry is here. Okay, the slurry is here. Now what happens after some time? What happens after some time is that this slurry, some of the slurry will travel down. Yes, some of the slurry will travel down. So we have some slurry on the bottom here. Some slurry is at the bottom, but some slurry will be left on top. Yes. So some amount of slurry will pass down the cheesecloth or muslin cloth and it will end up here in the bottom. Some amount of slurry will be on the bottom and some amount of slurry will be on top. Now students, what is this difference now? What is the difference now? What is the difference? Now, listen to me very carefully. Listen to me very carefully, all of you now. This is the differentiating factor. This is the differentiating factor here. Now, whatever we have in the bottom, the slurry which travel down is called as acid soluble fraction. Because technically speaking, this right here was soluble in acid. Which acid? Right here, trichloroacetic acid. The whatever slurry is in the bottom was technically soluble in the slurry, was completely soluble in the solvent, and it traveled down. It's called as acid soluble fraction. Okay. Now whatever which is present on the top, what do we call this one? Whatever is present on top, let me write it here. It will be easier. Whatever is on the top is called as acid insoluble because it was not soluble in acid. Whatever is present on the top, it was not soluble in trichloroacetic acid and it is left on top. That is acid insoluble. It's called as acid insoluble fraction. Acid insoluble fraction. Okay, done. Now, students, listen to me very carefully, all of you now. Now, this acid soluble fraction, this acid soluble fraction, can I also call it filtrate? Filtrate. Because it is being filtered down. It can also be called as filtrate. Now, what about the one which is present on the top? It is called as retentate. It's called as retentate. Okay, retentate. Present on top, retentate. Which is coming down, that is called as filtrate. Done. Filtrate. Beautiful. Filtrate. Now students, Whatever present on down is also called as your micromolecules. They're called as micromolecules because their size, the size of the molecules here, which is present on the down, is actually less than 1000 Daltons. Less than 1000 Daltons. The molecules which are present on the top, which are not acid insoluble, which are represent the retentate, are called as macromolecules. They are called as macromolecules because their size is more than 1000 Daltons. 1000 Daltons. That is your first experiment. Any doubt here, quickly ask me. First, what did we take? We took a liver piece or a leaf. We added into a mortar and pestle. Yes, this is a mortar, and this is pestle, right? This is pestle, mortar and pestle, and we completely grinded it here. Once we grinded, we got a slurry. We got a slurry here. We obtained a slurry. Now we took the slurry and we added into a beaker. Now once on this particular beaker, we also have a muslin cloth which acts like a filtering paper, which acts like a filter paper. Okay. Now once we add the slurry, some amount of slurry will come down, some amount of slurry will be on top. The slurry which is coming down is called as acid soluble fraction, filtrate, micromolecules, because their size is less than 1000 Daltons. Very simple biology. Now at the same time, some amount of slurry is on the top. That part is called as acid insoluble fraction because this slurry right here is not soluble in trichloroacetic acid, and we call it retentate macromolecules because their size is more than 1000 Daltons. That is the first experiment which is also given you NCERT. Clear, right, all of you? Easy, right? Nice. Now students, that was just the first one. Now will they ask you directly about filtrate and retentate? No. How will they ask you questions here? The question will be always asked in the form of examples, because biology is a topic which always requires examples. Here we have examples again, students. For your biomicromolecules which are coming down, we have simple sugars which has such basically is monosaccharides, all the monosaccharides, amino acids, small amino acids, and nucleotides, small ones are coming down. Okay. At the same time, macromolecules which are present on the top. Example is complex carbohydrates. The complex carbohydrates includes oligosaccharides. Yes, oligosaccharides, polysaccharides, disaccharides. Here, proteins as well as nucleic acids. All of their size is more than 1000 Daltons. But between all of this, one imposter is there. I call it kalla or cheater or hacker. Who is the hacker here? The hacker here is nothing but lipid. Lipid is the hacker here. Why, sir? Why do you call lipid the hacker? Because students, the size of the lipid is actually less than 1000 Daltons. The size of lipids is less than 1000 Daltons. But didn't we learn here, students? Didn't we learn here? Macromolecules size should be more than 1000 Daltons. But you are telling me now, right now, lipid is less than 1000 Daltons. How is it possible? Students? How is it possible that even though lipids size is less than 1000 Daltons, how can they be present in retentate? What is the answer? Answer is very simple, students. Your lipids are playing chain. What are they doing? They are playing chain here. What is the chain? All the lipids are holding hands. And they are forming something called as vesicles. And with the formation of vesicles, the chain, they are not coming down. So all the lipids are playing chain and they are holding and they form something called as vesicles here. And they are present on retentate. Done? Is it point clear to all of you? Yes. That is why it's kept in macromolecules. Also acid insoluble fraction or retentate. That is the beauty of lipids. One concept done already. Okay. Now students, This is the solution. See here, look at this. Didn't we just learn that hydrogen in the body is comparatively more, carbon in the human body is more, the oxygen in the human body is more, nitrogen is more. So I told you, in the case of human body, the same elements are in a higher concentration. The same elements in the case of earth crust will be in a much more lower concentration. Simple biology, students. Simple biology. The entire chapter is so simple. You understand the concept. Okay. Now, are you ready to do one more experiment now? That is, here it says that, what about, sir, sodium, what about sulfur, calcium, magnesium, silicon? How do we obtain that? How do we do the analysis for that? To analyze such different elements, there is one more experiment. The one more experiment is called as Ash test. So can we do that Ash test now? So how to remember the table? They will never ask you this table, students. They will never ask you this table. Only thing they'll ask you is the difference. That's all. They'll not ask you this table. Which table they'll ask you, I will tell you that. Which table they'll ask you. Okay. Now listen to me very carefully, all of you. Second experiment coming up. Second experiment is very simple. Second experiment is very simple. You need to take a fresh leaf. Take a fresh leaf. One second. Take a fresh leaf here. We have a fresh leaf here. Okay, this is your fresh leaf. All of your scientists now, this is your fresh leaf. Okay, this is your fresh leaf. It has water. Yes, it has water. So can I call it wet weight? Wet weight is there. Okay. Wet weight is there. Or it has water present in it. It has water present in it. Now what you need to do is evaporation. What you need to do is evaporation. Completely evaporate it. Now you can keep it in oven. You can keep it in normal oven or keep it in sun dry shaded place. So evaporation takes place. Now tell me what happens in evaporation. Is there water loss or water gain? Evaporation, water loss or water gain? When there is evaporation, there will be minus H2O. Water is being lost. Now we have a dry sad leaf. We have a dry sad leaf now. Okay, dry sad leaf is there. Dry sad leaf. Now can I call it dry weight now? Yes, dry weight. Dry weight. Dry weight is here. Now what you need to do is completely grind it. Grind it in a mortar. Mixie. Use mixie and completely grind it now. Okay. Now once grinding is done, you get some powder. Okay, you get some powder. You take this powder and you burn the powder. Completely burn the powder. Burn the powder. That is called as incineration. Completely burning it. Incineration. Now once you burn it, right? Once you burn it, you obviously end up getting ash. Now when you are burning it, what is happening? Oxidation is happening. Yes, oxidation is happening. That is basically combustion here. That is basically combustion. Yes, combustion is happening. Now this ash here will be sent to the labs. There are different types of methods for this ash. To analyze the ash, that is, we do analysis now. We do basic analysis. So when we do the simple process, it's called as ash analysis. We obtain the properties of all the inorganic substances. Why inorganic substances? Because students, when you're burning here, when oxidation is happening, all the organic substance is lost. All the carbon, everything is gone. So if you want to test inorganic substance, ash test is the go. Ash test. Ash, not like from Pokemon, normal ash. Ash test. Ash test. Clear all of you? Very easy, right? Very easy. So when you do the ash test, you end up obtaining the different types of components. That is sodium, potassium, calcium, magnesium, water, and different compounds can be obtained. Now obviously not water, because water will be evaporated. Okay. Now with that, the first part of the class is over. Any doubt till here, quickly ask me, because I'm going to make sure you understand NCERT side by side. Any doubt till here? Students, are you able to see the board? Tell me, are you able to see the board? Are you able to see? Yes or no in the chat quickly? Is it clear? Now see this. I hope it's clear, right? See here. In various organisms, biosphere, elements and compounds. You have learned in the chemistry how elements and analysis is performed. Now see here. If we perform such analysis on plant tissues, animal tissues and microbial paste, we obtain list of elements like carbon, hydrogen, oxygen and several other their respective content per unit mass of living cells. If the same analysis is performed on piece of earth crust as an example of non-living matter, we obtain similar list. I told you, right? When we do the analysis of the elements on earth crust and living tissue, same elements are there. Hydrogen, carbon, oxygen, same elements are there. But what is the difference then? That is, what are the differences between the two lists? In present in sample of earth crust, also present in sample of living organism. However, a closer examination reveals that the relative abundance of carbon and hydrogen with respect to other elements is higher in living organisms than in earth crust. That is the first difference. In case of our body, carbon and hydrogen is in much more higher abundance. Done. Now analysis. Okay. How do we go on finding this answer? That is, what type of organic compounds are there? What do? We can take any living tissue, vegetable or a piece of liver or a leaf and grind it with trichloroacetic acid, Cl3COOH, using a mortar and pestle. Experiment in your mind, all of you. Keep doing the experiment in your mind, which we just did 2 minutes ago. Right? We obtain a thick slurry. Okay. If we were to strain this through a cheesecloth or a cloth, muslin cloth, which I told you, muslin cloth or cheesecloth, we would obtain two fractions. Remember the fraction. One is acid soluble, one is acid insoluble fraction. See, one is called as filtrate, which is coming down, or more technically acid soluble pool, which is coming down, acid soluble pool. And the second one, retentate on the top, acid insoluble fraction. Scientists have been found thousands of organic compounds in acid soluble pool. So acid soluble pool down, we can find a lot of different types of compounds. See here. In higher studies, you will learn about how to analysis is done, which you will do in higher classes than MBBS. Okay, done. This is basically biomolecules. All the both students, when we apply the components, give all the carbon compounds that we get from living tissues can be called biomolecules. Can be called as biomolecules. All the biomolecules are carbon based. Okay. Now the next experiment is here. Can you see? A slightly different but destructive method to be done. Destructive why? Because we are using fire here. Fire, destructive method, fire. One way, a small amount of living tissue, say a leaf or a liver, and call it wet waste. Remember starting wet waste, and dry it. All the water evaporates. Evaporation done. The remaining material is called as dry weight. Now your tissue is finally burnt, ash, and the carbon compounds are oxidized. I told you, carbon compounds are getting oxidized, combustion is happening, and are removed. What is remaining is called as the ash. This ash contains inorganic elements. Did I tell you that? The ash will contain inorganic elements. That is very important. Okay, inorganic elements, right? So like sulfate, phosphate, also seen in the acid soluble fraction. Therefore, elemental analysis gives the elemental composition of living tissues in the form of hydrogen, oxygen, chlorine, carbon. Everything can be seen. That's all. The rest everything is same thing is given. You can read it. Nothing. We have not missed out any point here. Not missed out any point. So students, tell me in the chat if everything is clear to you, and if you want me to make sure NCERT reading is important, tell me yes sir in the chat. Otherwise, we will not do NCERT reading. I want everyone to quickly smash the like button, and also let me know in the comment section later on if NCERT reading is useful, because it is important to know that whatever we understood is there in NCERT. Right, whatever we understood is in NCERT, if that is important for all of you. Okay. Now, if that is done, we'll remove this now. Let's go to amino acid now. Let's go to amino acid now. One by one, we'll take everything. Okay. This whole chapter is easy, students. This whole chapter is very easy. Just understand what I'm saying. Follow the notes. Follow the NCERT. You're good to go. This chapter is removed from your backlogs. Okay. Now, amino acids. Amino acids. What do you know about amino acids? First of all, let's go one by one. Very slow, very slow. Okay, let's go one by one. Now tell me, what do you know about amino acids? What comes to your mind when you think of amino acids? What comes to your mind when you think about amino acids? Like if someone says on the road, if someone on the road says amino acid, what will come to your mind? So if you're studying student, you will say, sir, amino acids are basically monomers. Amino acids, one second. Amino acids are basically monomers. This much you would know. This much you would know. Now, what are the monomers of? What are they monomers of? That is, one amino acid, one more amino acid. When many amino acids are joined together, they end up making the protein. They end up making the protein. Clear? And these are the same amino acids which are the building blocks of our body. They are the building blocks of the body. Right? Building blocks of the body. Now students, remember the same type of amino acids were taken by the people who go to gym. They take a lot of protein. Right? They take a lot of protein. Now students, the next question, see, this is what we learned. Amino acid which makes up the protein. Right? Now, there are many amino acids. So there are many types of proteins. There are plenty of proteins such as your growth hormones. Hormones are proteins. Creatine, collagen, rhodopsin, fibrinogen, trypsin, melanin, actin, glycogen. There are millions of proteins. But how many amino acids might be there? If there are millions of proteins, obviously we need to have around 100 amino acids minimum. Minimum 100 amino acids or 200 amino acids, or at least 50 amino acids should be there, right? At least 50 amino acids should be there to make up the large millions of proteins. But no, we do not have 50 amino acids. We just have around 20 amino acids, students. Just 20 amino acids are there. Only 20 amino acids. Only 20 amino acids. That's all. 20 amino acids. So you might be wondering, how do we get these amino acids in the body? Friends, remember, all the amino acids which is coming to our body is with the help of diet. All the food. Can you see? Tell me which is your favorite food from this. Tell me which is your favorite food. My favorite, I'll tell you what is this in this. My favorite is going to be eggs here. Eggs is my favorite, and this walnuts are my favorite. Now, all these amino acids can be classified into two parts. Broadly speaking. One is called as essential amino acids, other one is called as non-essential amino acids. But what is the difference, sir? What is the difference? Friends, remember very carefully, essential amino acids. Essential amino acids are the amino acids which body does not produce actually. Body does not produce. If body is not producing it, how do we get it? If body is not producing it, we obtain this amino acids. From our diet. We obtain the essential amino acids from the diet. Now, what about non-essential amino acids? Non-essential amino acids are the amino acids which are prepared by the body, which are produced or prepared by the body, produced by the body. Done? Any doubt here quickly? Any doubt here? Fish oil, omega-3 fish oil is the best thing. Okay? I think there should be no doubt here. Now I want everyone to know a fact that how the question will be asked. Okay? In your examination, they will not ask you essential and non-essential. They will never ask you that. How will they ask you? They'll ask you in a way that which of the following is essential, which of the following is non-essential. Do you have to remember this? Yes, you have to remember this. But how will you remember this? Is there any small trick for it? Yes, there is a small trick. So do you want the trick? Tell me in the chat. Do you want the trick? Do you want the trick to remember the essential and non-essential amino acids? A small trick is there. Okay, and it is not my trick. I have picked it up from somewhere. Obviously, not my trick. See here. For essential amino acids, the trick is very simple. Private Tim Hall. The private Tim Hall. That is phenylalanine, valine, threonine. Tryptophan, isoleucine, methionine. Histidine, arginine, lysine and leucine. Done. Lysine and leucine. For essential amino acids. For non-essential amino acids, almost all guys get cut after going to play sports. Now students, all of you might have your own tricks, but this is a simple trick which I know, and let me tell you honestly, if you don't practice this trick, examination it's going to go bad. You will not remember it. So for example, here we have tyrosine, T for tyrosine. Here also we have somewhere T for tryptophan. If you don't practice it, you will write tyrosine here, tryptophan there. So please be careful. Please be careful when you are learning the tricks. Practice it once before going to the examination. Practice is almost every single day. Tricks are good, mnemonics are good, but unless you practice those mnemonics, there is a very high chance that you might go wrong. Very high chance. Okay. Now, with that being done, are we ready to learn the structures now? Students, I do not want you to go after the class and be like, sir, I will do it later on. I want you to learn right now in the class, learn with me and understand with me, write down with me. Okay, so all of you open your books now quickly. All of you open your book. Done? No, you can just remember essential amino acids, but you should also know the entire amino acids. Then you will be able to distinguish between essential and non-essential. Okay, ready everyone? Books done. Now, let's understand the structure now, because I don't want you to take away like later on, study later on. No, everything should be done within the class. Right? Now, let's start with the essential, with the structure of amino acids. Now, first of all, if you know about the structure, first you should know about the structure, that what is the structure of amino acid? What is the structure of amino acid? The structure of amino acid is very simple. That is, amino acids are basically substituted, because we will be substituting now. They are basically substituted methanes. Substituted methanes. What is the methane, students? Methane is nothing but CH4. Yes, we have CH4 now. CH4. Now, are you ready for substituting now? All of you write down in the book now. All of you write down in your book. Done? Written? All of you written? First write carbon and 4 hydrogen. Okay. Now we'll be substituting this particular hydrogen with COOH. That is nothing but a carboxylic group. It is nothing but a carboxylic group. Done. Carboxylic group. Now we'll be replacing this H. We'll be replacing this H with NH2. NH2. That is nothing but amino group. Amino group. That is nothing but amino group. Amino group. Done. Now what about this H? This H on top. This H will remain as such. Now what about this H? This H will be replaced by a R group. What is R group? R group is basically a functional group. It is going to be a functional group. Now for every single amino acid, this is the backbone. This is going to be the complete backbone. The only difference between every single amino acid, I repeat again, the only difference between every single amino acid is going to be the functional group. It is going to be the functional group. Done? Is that point clear to all of you? Is that point clear to all of you? Clear? So every single amino acid will have a carboxylic group. Every single amino acid will have a amino group. Every single amino acid will have a hydrogen. The only difference is going to be functional group is going to be the difference. That's it. That is going to be a difference. Write down this point, all of you. Now, let's understand the structure. This is your carbon, carboxylic group, amino group, hydrogen. The only thing which is going to be different is R group here. For example, in this R group, if I write a hydrogen, in this R group, if I write a hydrogen, we end up getting glycine. Write down, if you write down, you will get a glycine. Simple. Now, will they ask you the structure? Yes, they will ask you the structure. They will ask you the structure. Now tell me in the chat quickly, what is a chiral carbon? What is a simple chemistry, right? What is a chiral carbon? Chiral carbon is a carbon which has 4 different groups. 4 different groups. Here, for example, is this a chiral carbon? No. This right here is not a chiral carbon because hydrogen is there, hydrogen is here, hydrogen is here. So this is not a chiral carbon. So can I tell your glycine is non-chiral in nature? Yes, it is non-chiral in nature. Non-chiral in nature. Yes, non-chiral amino acid, and in fact it is the only non-chiral amino acid. Non-chiral amino acid. And it is also the simplest amino acid, students. It is the most cutest and most simplest amino acid. Simplest amino acid. Most simplest amino acid. Okay. And it is optically inactive. It is going to be optically inactive. Optically inactive in nature. That is your glycine. That is going to be your glycine. Any doubt in glycine? Quickly ask me now. Any doubt in glycine? Did all of you write this down? Did all of you write down? Done? Optically inactive, glycine. Done. Now, what if I replace this R group with a CH3 group, a methyl group? If you replace the R group with a methyl group, we end up getting alanine. We end up getting alanine. Then end up getting alanine. Now similarly, students, if I replace the R group with CH2, CH2OH, see, that is nothing but your hydroxymethyl. This is going to be serine. It is going to be serine. Okay, write down all of you, write down. It's going to be serine. So let's take a small, and one second, students, one second. So what we learn right now? This is the basic structure of amino acid. NH2, hydrogen, and this is the R. There are 3 structures given in your NCERT. 3 structures. If it is just hydrogen, if it is going to be just hydrogen, it is going to be glycine. And if it is going to be CH3, that is a methyl group, it is going to be alanine. It is going to be alanine. If there is CH2OH, it is going to be serine. This is going to be the 3 structures which you need to learn. 3 structures which you need to learn. Tell me once this is done. All of you wrote it down. Make your notes. Make your notes. And students, if you're not making your notes, and if you want notes, if you want the notes will be given on the Telegram channel. Notes will be provided on here. Okay, notes will be provided on right here. Telegram channel. This is a Telegram channel. On this Telegram, all the notes will be given to you. Done? Very simple. Very simple. Is there any difficulty in biomolecules? Tell me now. Tell me. Is there any difficulty in biomolecules? Hydroxymethyl. It's going to be serine. CH3 methyl. Alanine. Hydrogen. Glycine. Done. Very simple. Now students, if you want to classify the amino acids, there is one more classification now. There is sulfur containing. Now I have given you the structure here. You do not need to remember the structure. Structure is not important. The only reason I have given the structure right here is for you to understand. That's all. But you need to remember that is sulfur containing amino acids are methionine and cysteine. Methionine and cysteine are sulfur containing. Done. Structure not important, chemistry you might learn, but the words amino acids important. Methionine and cysteine. Now tell me, where do you learn methionine? This word have you heard anywhere? This methionine, have you ever heard in a chapter called as molecular base of inheritance? This methionine right here, methionine. Have you heard about it? Methionine. Yes. It's also called as a start codon. Yes. It is the same methionine which is a sulfur containing. Done. Simple. Now students, you also can classify some of the amino acids. Some of the amino acids can have some nice ring they can have. Do all of you wear rings? Meghana, Manjula, Hasini, Janvi, Jai, Savita. Do all of you wear rings? Some of you might be wearing rings. Some of you don't wear rings. Similarly, some amino acids can wear rings. Some amino acids do not have rings. Simple. That is, entire amino acids can be divided into two categories. Again, two categories. That is, some of them are aromatic in nature. Aromatic in nature. That is, aromatic amino acids. Aromatic amino acids. Yes, they have certain aromatic rings. Aromatic rings such as benzene ring. Such as a benzene ring. Very simple. Something like this. They can have a benzene ring. Yes. Some of the amino acids are non-aromatic. They are non-aromatic. They don't want to show off. They're like, no sir, I can't wear ring. Ring is very, I will lose the ring. That is my category. Never take a ring because I will lose the ring. See, non-aromatic amino acids can also be called as aliphatic amino acids. Aliphatic. They are also called as aliphatic amino acids. Aliphatic amino acids. Aliphatic amino acids do not have rings. They do not have rings, but they have some long chain. They have basically straight chain. They are basically straight chains. Sorry, what are you teaching? You are teaching chemistry or biology? This is biochemistry, students. This is biochemistry. This is biochemistry. The reason many students fail to understand this chapter is because you treat this chapter as a biology chapter. This chapter is actually half chemistry, half biology. Okay. Is there any doubt here? Quickly tell me. Amino acids can be aromatic, non-aromatic. Aromatic amino acids can have benzene ring. Non-aromatics or aliphatic can have straight chains. They can have straight chains. Done. Very basic. Very basic. Now, what you need to remember here is the examples. Examples are the most important. For example, there are 3 different examples given here. That is aromatic amino acids. 3 examples. One is phenylalanine, tryptophan and tyrosine. Now, structure I have given you, but structure is not important. They will not ever ask you the structure, but they will ask you the names. They will ask you the names. Structure I have given you for you to understand. Yes, benzene ring is there. Yes, benzene ring is there. Yes, benzene ring is present. That is phenylalanine. Now you might be wondering, have you heard about phenylalanine somewhere in any chapter? Any chapter? There is a chapter called as Principles of Inheritance. In Principles of Inheritance, is there a disease called as PKU disease? Phenylketonuria disease? Yes, there is a disease called as PKU disease. Phenylketonuria disease. Yes. What happens in this, students? In phenylketonuria disease, there is a decrease in the enzyme hydrolase, phenylketonuria hydrolase. When there is a decrease in hydrolase, phenylalanine will increase in the blood, causing PKU. Remember the chapter. So that's how we are connecting the chapters now. That's how we are connecting the chapters. Now, what is tryptophan? Yes, tryptophan you might have learned when I was teaching you about plant growth regulators. Did we learn that tryptophan is actually an auxin precursor? It is used in auxin preparation. Auxin preparation. Yes, it is used in auxin preparation. That is tryptophan in auxin preparation. Yes. Now, what about tyrosine? Tyrosine is also called as emergency hormone. Also called as emergency hormone. Emergency hormone. Emergency hormone. Yes, that is a tyrosine. Emergency hormone. It is also present, if I remember correctly, thyroid. For production of thyroid, yes, thyroid hormone. Thyroid hormone. Student, that's how you connect chapters. That's how you connect different chapters and learn. So, if I ask you a question, will you all be able to answer now? Tell me, which is the sulfur containing amino acids in the chat? Quickly go. Sulfur containing amino acids. I will ask again this also later on. Sulfur containing amino acids in the chat. Go. So that was one classification. Now one more classification is based on the acidity. That is acid amino acid, basic amino acid, and also there is neutral amino acids. Three different types of amino acids, and what is the difference? We will learn right now. What is the difference between acid, basic and neutral amino acids? Can we start? Students, tell me, is the chapter anything difficult till now? Any difficulty? Are you facing any difficulty? No. It's a very easy chapter. It only demands your attention. It only demands your dedication. And if you have a right teacher, it will teach you this chapter in a much more easier manner. That's it. Okay. Now, for example, let's go with acidic amino acids now. Let's go with acidic amino acids. Now, students, what is there in acidic amino acids? In acidic amino acids, you will have an extra carboxylic group. So, notice here, there is one carboxylic group here that is in the basic frame structure. In the basic frame, we have carbon, we have NH2 group, that is amino group here, we have amino group here, and we also have the carboxyl group here normally. But apart from this carboxyl group, there is an extra carboxyl group here. Can you see? Extra carboxyl group. That is, example is aspartic acid. At the same time, if you look at the glutamic acid also, there is an extra carboxylic acid. So what is acidic amino acid? Acidic amino acids will have an extra carboxylic acid group. Carboxylic acid group. Extra carboxylic acid group will be there. Okay, that is in the case of acidic amino acids. Done. Example is aspartic acid and glutamic acid. Very easy to understand. Very easy to understand. Two carboxylic groups. Now, what will be there in the basic? Tell me now then. What will be there in the basic? What will be there in the basic? Tell me. Yes, valine is neutral. Manju, they have given you only one example. 15 are neutral. I'll tell you that. Not only valine, even glycine is neutral, isoleucine is neutral, leucine is neutral. Right? So there are 15 neutral amino acids. We'll come to that. This is acidic amino acids. So basic amino acid will be what? Basic amino acid will have extra NH2 group then. Yes, extra amino group. Can you see here? This is the basic framework. Carboxylic acid, NH2H. This is the R group, functional group. In the functional group, can you see one extra amino group? Yes. Here also can we see an extra amino group? Yes. Here also can we see an extra amino group? Yes. So in basic amino acids, there is an extra amino group. Extra amino group. Done. Extra amino group. Examples, all of you know this. Lysine and arginine and histidine. Three different examples. But where do you learn this, friends? Where have you learned this? You have learned this in molecular base of inheritance. Do you remember in packaging of DNA? In packaging of DNA, histone proteins, we learned that the basicity is because of two amino acids. That is lysine and arginine. Lysine and arginine you learn there. The basic amino acids. Now quickly tell me in the chat, which are the aromatic amino acids? I'm going to keep testing you. I'm going to keep on testing you today. Which is the aromatic amino acids now? Quickly in the chat, go. Aromatic amino acids. Students, write down this. This is the only part where you need to remember. And there is no concept here to understand. Like, it's very easy to understand. The only concept which I'll teach you right now is the concept of, no, neutral is neutral nothing. Neutral will have, there will be neutral amino acids. Valine, NCERT tells you valine. NCERT is telling you valine as an example, but there are 15 of them. For example, students, if you count, if one second, student, let me change the color here. If you count the total number of amino acids, like if you count, right, total amino acids, 15 will be neutral. 15 will be neutral plus 15 will be neutral. Did we just learn 3 basic amino acids? Did we just learn 3 basic amino acids? Yes. Lysine, arginine, histidine. Plus, did we learn 2 acidic amino acids? Aspartic acid and glutamic acid? Yes. 2 are acidic in nature. Acidic in nature. Now quickly count now. 15 plus 3 plus 2. That is going to be around 20 amino acids. 20 amino acids in total, students. 20 amino acids in total. That is your count. That is the count. Structures, no. Structures, no. Don't learn any structures. Just learn the names. Just learn the names. Done? Done, students? Very easy, right? Very easy. Now, there is a concept called as zwitterion. There's a concept called as zwitterion concept. Again, nothing to break your head. Nothing to break your head. I will explain in next 5 minutes. You will tell me, sir, it is so easy to learn. Study. Can we start? Can we start, students, now? Can we start? Yes? Let's start. Okay. Now, what is this zwitterion formation? Now, students, you should know that when you are in games period, are you more happy, or when you are in physics or physics class, or in a school, when you are in physics class or maths class, when are you more happy? Tell me. When you are in games period, you will be nicely playing in games period, you are more happy. In math class, you are like, oh, what is this sir telling now? I have to learn math, sin theta, cos theta, tan theta. You will think like that, right? In the head. In the head will be there. Sin theta, cos theta, all things will be running in your head. So all that is telling you is that you are you. You are in whenever there is a different surroundings, your mood will change. Your mood will change based on the surroundings, right? Your mood will change based on surroundings. Similarly, your amino acids will change based on the surrounding. Amino acid will also change based on surrounding. Example, see here. That is, on different pH, in different pH, that is different surroundings, different state of amino acid. Amino acid can be anion or it can be cation based on the pH. For example, listen to me very carefully now. For example, first we'll take one amino acid. First we'll take one amino acid here. COH. Here we have NH2. Here we have hydrogen. Yes. And let's take some functional group here. Functional group. Now, when you keep this particular amino acid, in acid medium, in acidic medium, what is the meaning of acidic medium? Acidic medium means pH high or low. The pH will be very low. So what happens in acidic medium, students? In acidic medium, there will be H plus here. Yes, there will be H plus. Now, one H plus will be taken up by NH2. One H plus will be taken by NH2. So what will it look like? C OH, carboxylic acid, hydrogen, functional group. This side will have NH3 plus, NH3 plus. Now, the amino acid in acidic medium, will become basic in nature. The amino acid will become basic in nature. Done. It will become a basic amino acid in acidic pH. Now let's take a similar example. Let's take one more amino acid here. One more amino acid here. NH2, hydrogen, and functional group. Now this is in a basic medium now. In basic medium, pH is going to be very high. pH is very high. In basic medium, what happens? In the case of basic medium, one H plus is lost. So what happens here? Minus NH2, H, and this is going to be R. So in basic medium, amino acid will become acidic. In basic medium, amino acid is becoming acidic in nature. Understanding how it takes place. Now, if you go back to the diagram which is given in your NCERT also, when you keep the amino acid in a high pH, last diagram, we get what? We get anion. Can you see? COO minus H and NH2 in anion. So can I write anion here? Okay, anion. When you keep an amino acid at low pH, Low pH, what happens? NH3 plus, we get a cation. Is this simple concept clear to all of you? Simple concept, right? Now I'll tell you one more one of the most simpler concept. I'll tell you one more concept. I'll tell you simple concept. One of the most simpler concept. I'll tell you. At one particular pH, what happens is, this is COH here. This is what do we have? We have NH2. Here we have H, and we have here R. At a one specific pH, students, at a very specific pH, there will be what? At a particular pH, write it. At a particular pH, what happens? Intramolecular proton transfer. Sir, it sounds very fancy. Sir, it sounds very difficult. Can you explain it in a very easy manner? Yes, sir. What is intramolecular proton transfer, students? The meaning of intramolecular proton transfer is nothing but this proton is being sent here. That's it. This proton is being sent here. And when we send this proton to this side, what will happen? We end up getting something like this. Let me show you. Let me write on top here. What do we get? We end up getting a particular type of ion. We get a particular type of ion at a particular pH. Because of intramolecular proton transfer, we end up getting this because one hydrogen is being sent here. This one right here is called as amphoteric ion. It's called as what? Amphoteric ion. The same amphoteric ion, students, the same amphoteric ion is also called as, Zwitter ion. Also called as Zwitter ion, not Twitter, Zwitter ion. Done. That is a molecule with one functional group having positive charge on one side and other functional group having negative charge on the other side. That is your amphoteric ion. Positive charge on one side and negative charge on one side. That is your Zwitter ion. That is positive charge equals negative charge. Then net charge is going to be zero. But I told you here, at a particular pH, this happens. What is that particular pH? The particular pH is nothing but isoelectric pH. We call that pH called as isoelectric pH. So at isoelectric pH, we get Zwitter ion. What is Zwitter ion? Zwitter ion is a type of ion which has one negative charge, one functional group. One functional group is negative charge, other functional group is positive charge. The net charge is going to be completely shunya or zero. Mote tale. Did all of you understand what is Zwitter ion? All of you understand Zwitter ion? This is called as Zwitter ion. That's it. Is there any big concept here? No. Here, this is your Zwitter ion here. One negative charge on one side, positive charge on the other side. At a particular pH, the pH is called as isoelectric pH. At isoelectric pH, there is intramolecular proton transfer. So we end up getting one functional group. One functional group as negative charge, one type of functional group which is positive charge. And the net charge is zero here. Net charge is going to be zero. Done. Beautiful, right? Beautiful. This is the concept which all of you want to perfect. A lot of questions have come from here. Many students still struggle to understand what is the difference with what is basically Zwitter ion. Now you know what is zwitterion. Done. I want to drink water, but after a concept. See this question, students. Before we see the question, can we see the NCERT lines now? Can we look at the NCERT lines one by one? See here. All of you read here. Amino acids are organic compounds containing an amino group and an acidic group as substituents on the same carbon. That is your CH4. One side we have carboxyl, one side we have the amino group, the alpha carbon. The middle carbon is called as the alpha carbon. They are called as alpha amino acids. Hence they are called as alpha amino acids. This right here is alpha carbon. Here. Alpha carbon. Okay. Everywhere it is alpha carbon. Everywhere it is alpha carbon. They are called as alpha amino acids. Okay. And variable group, that is R. Based on the nature of R group, there are many amino acids. However, those which occur in proteins are only 20 types. There are only 20 types are there. Only 20 types are there. Right. The R group in this proteinaceous amino acids could be hydrogen, then it is glycine, methyl group, alanine, hydroxyl group, hydroxymethyl, then serine. 3 out of the 20 are shown in the figure 9.1. Figure 9.1. Let's go there. Here. Glycine structure is important. Alanine and CH3. Serine is CH2OH. This diagram done. Okay. Now, the chemical and physical properties of amino acids are essentially the amino, carboxyl and functional groups. Based on the number of amino acids and carboxyl groups, there are acidic groups. But as I told you, in glutamic acid, there is more number of what? In glutamic acid, there is more number of carboxyl groups. See that it says here, based on the number of amino and carboxyl. So in the case of glutamic acid, more carboxyl group. In the case of lysine, there is more amino group. Neutral valine is given here, only one is given here. Similarly, there are aromatic amino acids, tyrosine, phenylalanine and tryptophan. We did that. A particular property of amino acid, I told you, there is a property of amino acid. What is the property? The property of amino acid is the ionizable nature of NH2 and COH group. Ionizable nature. They can become cation or anion. Right? Here is a solution of different pH. Hence, in a solution of different pH, the structure of amino acid changes. How you will be different in games period, how you will be different in maths period. Similarly, amino acids can change their structure based on the pH around them. We learned that. See here. This is right here. H plus is here. O minus. This middle part is called as your zwitterion, because there is one functional group is negative, one functional group is positive, and at a particular pH called as isoelectric pH. Done. This is your zwitterion. Students, that was the end of amino acids. That was the end of amino acids. See the question. Amino acids have a property of ionizable nature of NH2 and COH group. Hence, they can have different structure at different pH. Yes, sir, we just learned that. Amino acids can exit as zwitterions, forms at acidic and basic pH. No. They will be acidic and not basic pH at a isoelectric pH. At a isoelectric pH. Not acidic and basic. At acidic pH, it will be somewhere else, something else. In basic pH, it will be something else. But at a particular pH, called as isoelectric pH, it will be a zwitterion. So, 1 is correct, 2 is wrong. You can do that later on. See this. Identify the basic amino acid. Basic amino acid. Tell me. Which is the basic amino acid now? Which is the basic amino acid? Basic amino acid is going to be lysine. Lysine. We just now learned. Students, this is a NEET PYQ. This right here is a NEET PYQ. Okay, it's a NEET PYQ. Not easy question. Not easy question. Okay. Look at this question now. Which of the following can be found as zwitterion? Which of the following can be found as bitter ion? This is a NEET 2024 question. This year. Tell me, nucleic acids, monosaccharides, fatty acids or amino acids? Which of the following can be found as a bitter ion? That is going to be amino acid. We just now learned. Easy 4 marks for you. Easy 4 marks. Students, this chapter is very easy. If you want to get those 6 to 8 questions, sometimes even 8 questions can come here. 6 to 8 questions. You need to watch the entire lecture. If you watch the entire lecture, you will be able to get all your marks. And students, let me know in the comment section today's video how was the session till now also. Because we are going in a very smooth way, right? Very smooth it's going. No difficulties whatsoever anywhere, right? Now, with that being said, can we start with lipids now? Second topic for today. Technically third topic, but can we start now? Can we start? Easy marks, students, easy marks. This chapter is nothing to be worried about. Chapter is very easy, only if you understand it. Okay. Now, the next topic is very simple, students. The next thing is, have you ever tried mixing oil plus water? Ever? Have you ever tried mixing, take oil, take water and try mixing it? Does it mix? Tell me in the chat. Does oil and water mix? You'll be like, no sir, no. Oil matter doesn't mix at all. In fact, oil will float on top above the water because of change in densities. You're correct. Now what if you agitate it? Take a bottle and take water in it and try adding some oil on top of it. Now you try to mix it nicely, When you try to nicely mix it, will it mix then? Yes, it will mix. Yes, it will mix that time. Now all of you know the basic chemistry. When we have two immiscible liquids mixing together, suspended phase, release phase, both are in liquid, can we get something called as emulsion? Yes. So we end up getting emulsion. We end up getting an emulsion, students. We end up getting an emulsion. So when you try to mix water and oil, we end up getting an emulsion. That is when two immiscible liquids are mixing together. When they are mixing together. Okay, that's emulsion. And do you want to know which is the strongest emulsion, the best emulsion in the world? The best emulsion in the world is nothing but milk. Milk is an emulsion. Milk is an emulsion. Remember that point. Okay, remember that point, all of you. Now students, can we start the lipids with a simple few points? Now did we discuss this before? We discussed this before. Lipids weigh less than 800 daltons, like hacker by 800 daltons, but still are present in the acidic insoluble fraction. That is, they are present on the top here. Present on the top. How? Because they are playing chain. All the different lipids, they are making something called as vesicles. And they are present on the acid insoluble fraction. They are present on acid insoluble fraction. Now students, what are lipids basically? Obviously sir, lipids are nothing but organic compounds. They are organic compounds. Yes, they are organic compounds. What about their molecular weight? The molecular weight is obviously less than 800 daltons, around 800 daltons. Yes, 800 daltons. They are technically insoluble unless you put agitation. They are insoluble in water. Yes, insoluble in water. Okay. Now one more important point, that is, they are not polymeric. In nature. Like they are not polymeric means, like, you know how polysaccharides are found. Polysaccharides are found by long chain of monomers. Lipids are not like that. They'll form vesicles. They will not form polymers. They'll not make polymers. Okay, they'll not make polymers. Now students, can we classify lipids now? Let's simple classification of lipids. The most simple form of classification of lipids is into 3 parts: simple lipids, compound lipids, and derived lipids. Lipids can be classified into simple lipids, compound lipids, as well as derived lipids. Now in your NCERT, they have not done the classification. But we have to do the classification. Because When you do the classification, you will understand better. Now let's start with simple lipids now, students. Can we start with simple lipids? Compound lipids, only one is there, which is I'm not going to explain in detail. Derived lipids, there is a diagram given in NCERT. There is a diagram for derived lipids. For compound lipids, there is a one word is given and one diagram is also given. But for simple lipids, there's a wide information given. So let's dive into it now. For example, simple lipids can be classified into two categories. One is fatty acids. It can be divided into fatty acids or it can be divided into glycerol. Fatty acids or glycerol. Okay, simple lipids can be divided into fatty acids or glycerol. Done. All of you write down the notes if possible with me. Write down the notes, write down the key points I'm telling you, or I'll be sending you the notes. Okay, don't worry about that. Notes will be sent on the Telegram channel, that is Basavaraj Sir Biology. On the Telegram channel, everything will be sent, don't worry. Now, let's start with fatty acids now. What are fatty acids? Are they fat? No. Technically they are, because they are long chains they can make. But then what is fatty acids made up of? Fatty acids are nothing but your carboxylic acids. They are nothing but carboxylic acids. Sir, you are teaching so much of chemistry. Students, remember, this chapter is half chemistry. Only. They are basically carboxylic acid plus an R group. This R group right here can be a methyl group, or it can be an ethyl group. Yes, it can be methyl group, it can be ethyl group, or it can be any group basically. 1 to 19 carbons. 1 to 19 carbons, any group it can be. Okay, that is your R. Okay, now let's draw a structure. This is your R, C, OH. That's all. Done. Simple structure. What is so difficult in this? This is the carboxyl part. This is the carboxylic acid part, and this is the functional group. Functional group and carboxylic acid part. Done. This is the structure of fatty acid. Fatty acid structure. That's all, very simple. Now we have to classify them. We can classify the fatty acids into two categories. Classify fatty acids into saturated and unsaturated fatty acids. Two different classification. Okay, two different. It can be saturated or it can be unsaturated. Very simple again. Listen to me very carefully. What are saturated? Saturated fatty acids are basically single bond. That is alkanes. Now unsaturated fatty acids are double bond, or they can also be triple bond. Right? Basically alkenes and alkynes. Okay, double bond and triple bond. Now this particular saturated fatty acids, melting point is very high. Here melting point is very low. Now have you seen ghee, tuppa, ghee? When you take the ghee from the kitchen, is it in a solid state or is it liquid? When you buy from the shop, sometimes it can be liquid starting, but when you take it to the house, we start using, will the ghee become solid at room temperature? Yes, it becomes solid at room temperature. Butter also is solid at room temperature? Yes. Only when you heat the ghee, it becomes liquid. When you heat the butter, it becomes liquid. So your butter and ghee are saturated fatty acids, that is, they are solid at room temperature. Ghee or butter. Give a butter. What about the unsaturated fatty acids? The cooking oil, the sunflower oil in your house, cooking oil, olive oil, right? Cooking oils, coconut oil, mustard oil, all that oils are basically unsaturated fatty acids, and they are mostly liquid at room temperature. Liquid at room temperature. Cooking oils. Cooking oils. Cooking oils will come here. Okay, cooking oils. Done. Is this different, students? Is this difficult? No. And will you get question from here? Will you get a question from here? Yes, you will get a question from here. Lots of questions have come from here. Lot of questions. Lots and lots of questions, friends. Lots of questions. For example, here an example is there. Here, there's an example. Gingerly oil. The example which is also given in your NCERT, gingerly oil, whose melting point is very low. Melting point is very low. Okay. Now, can we go for some examples, more examples? In examination, they will not ask you. In examination, they will not ask you ghee or butter or cooking oil. In fact, they will ask you something that they'll ask you other examples, which I'll teach you now. The other examples. The other examples are going to be for your saturated fatty acids. For saturated fatty acids, the example is going to be palmitic acid, which is 16 carbon, as well as stearic acid, which is 18 carbon. Stearic acid 18 carbon, palmitic acid 16 carbon. Now, unsaturated fatty acids. Unsaturated fatty acid, the main example is going to be arachidonic acid, which is 20 carbon. 20 carbon. Then palmitic acid 16, stearic acid 18, saturated. At the same time, unsaturated is going to be arachidonic acid, arachidonic acid, it is 20 carbon compound. 20 carbon. 20 carbon. If that is done, I will teach you an extra concept now. Extra concept called as MUFA and PUFA. What is MUFA and PUFA, students? MUFA and PUFA. MUFA is called as mono unsaturated fatty acid. Mono unsaturated fatty acids, that is, they will have, these are the unsaturated fatty acids. They are the unsaturated fatty acids with only one double bond. With only one double bond. Only one double bond. That is going to be MUFA. Example is oleic acid. Example is right here. That is oleic acid. Oleic acid is the example. What about polyunsaturated fatty acids? Poly means many. So they will have many double bonds. That is more than one double bonds. That is MUFA. Examples are right given here. All three of them. That is linoleic acid, linoleic acid, as well as arachidonic acid. Linolenic, linoleic acids. Clear? Done. Olive oil. Let's keep this. So with that, fatty acid concept is over. So it's an easy, students. I'll give you the notes. Go through the notes. I know if you're watching the lecture for the first time, it can get a little confusing. But if you watch the lecture over and over and read the points, understand the notes, make your own notes from these notes, then truly you will understand this chapter. For example, let's study with glycerol. What are glycerols? Glycerols are nothing but alcohols. That's all. They're basically alcohols. That is, this alcohol, that is your OH, glycerol is made up of 353. 3 carbon, 5 hydrogen and 3 OH. 353. Is the answer. That is alcohols. So glycerol is basically made up of alcohol. 3 carbon, 5 hydrogen and 3 OH. Let's draw the structure. You'll understand better. Let's draw the structure. So 3 carbons, right? 3 carbons. Let's draw here. 3 carbons. 1, 2, 3. 3 carbons. 3 hydrogen. OH, 5H, 1, 2, 3, 4, 5. This right here, students, this right here is the structure of glycerol. This right here is structure of glycerol. Now, in terms of chemistry, they have a separate name for this. In terms of chemistry, the separate name is trihydroxypropane. The other name of glycerol, the other name for glycerol is trihydroxyl propane. Trihydroxyl propane, that is the other name for glycerol. Apart from it, they will never ask you any question. They can ask you how it looks and feels like. That is basically, glycerol is basically colorless. It is colorless. It is somewhat very sweet, or it can be viscous also sometimes. It can be viscous. Done. Trihydroxyl propane. Done. Done. 1 second. Till here, lipids is very smooth again. Lipids is very smooth. Nothing, right? Like smooth like butter. Yes, lipids is smooth like butter right now. Nothing to worry. Entire chapter is easy. Okay. Now, for example, the next question which arises is, how are they joined? The next question is, I told you, lipids are made up of two things. We just now learned lipids are made up of fatty acid plus glycerol. Lipids are made of fatty acid glycerol. How are they joined? So glycerol, is it kind of alcohol? No. Glycerol, Manju, have you ever gotten a cut in your mouth? They tell you, the doctor tells you, apply some glycerol on top of it, cut inside the mouth, right? Like cut in your mouth, you would have gotten, they asked you to apply something in the mouth. That is glycerol. You apply in your mouth, right? Now, how are they joined together? The joining is nothing but esterification is happening, students. What is the joining? Joining is what? Joining between them is basically esterification is happening. Esterification happening. Now tell me in the chat, do you want to learn the detailed structure of esterification? Do you want me to draw the structures and teach you? Do you want me to teach the structures? Or do you want to just be okay with esterification? Yes sir, esterification is happening. You want to learn, right? That's the spirit. Now let's do a glycerol first. Let's do a simple glycerol. Okay, let's do a simple glycerol. How many carbon? 3 carbon. 1, 2, 1 second. I'll draw it on this side. 1, 2, 3. OH, and OH. H. This is a glycerol. This right here is glycerol. Okay, we have glycerol here. Now this glycerol, we are adding a fatty acid. Let's take a fatty acid. CH3, CH2, CH3, CH2. Let's take 14 times. And let's have to add a COH also, carboxylic acid. It's a fatty acid, right? Fatty acid is what? Fatty acid is basically R group plus carboxylic group. This is palmitic acid. Okay, palmitic acid. Now what happens? Now? This is very important. Now what happens here is this H here, first one. They are forming a bond like this, and this entire thing is completely removed out. This H right here, removed out as water. So H2O is been removed. H2O plus 1 is removed out. Now what do you get? What do you get if H2O is removed out? First we write your glycerol, 3 carbon, yes, I'll write H here, next to it only H, easy to write, yes, H is here. Now here we have OH, here, one hydrogen will come here, right? Okay, this, now one hydrogen is being, it's there, H2 is there, okay. Now we have oxygen here, oxygen is missing. Now to this oxygen, this C double bond O will join, so C double bond O, part of carboxylic acid, C double bond O is joining, then rest of things are coming as such. So, well, glycerol plus fatty acid will result in a structure. Glycerol plus fatty acid will result in a structure that is nothing but glyceride. It's going to be, have to bend so down, glyceride. Yes, this is going to be glyceride, and this is called as esterification is happening here. What is happening here? Esterification is happening here. That is a glyceride formation. Now here, only one OH was replaced. One H was replaced. So can I call it a monoglyceride? Yes. Now what if I add one more fatty acid here? Then it will become diglyceride. If I add one more fatty acid here, then it will become triglyceride. Do you understand? First it is monoglyceride, diglyceride, then triglyceride. That's how glyceride formation is happening. Students. Glyceride formation is happening. Are you understand? That's how you get monoglyceride, diglyceride and triglycerides. Easy, right? Easy. Yes. That's what we wanted. That's what is given here. Mono, di and tri, formed by the condensation of 3 fatty acids and one glycerol. That is triglyceride. Simple difference is given here. Similarity is what? Fats and oils. Fats are basically triglyceride, both are triglycerides. Solid room temperature, liquid room temperature. Mainly from animal source, fats. Oils from plant. That's why sunflower oil. Right? Sunflower oil, soybean oil, all you get here. Relative more saturated, unsaturated. Low, high melting point and low melting point. Ghee, I told you. Ghee, fat. Oil, the cooking oil is the answer. So easy, students. Chapter is so easy. Easy peasy lemon squeezy. Okay. That is the end of simple lipids. Now in compound lipids, again, very simple again. Lipid is made up of what? Tell me. Simple lipid was made up of one fatty acid and one glycerol. This was simple lipid. But in the case of compound lipid, we are adding one more compound. We are adding one more thing. That is, we have an additional group now. That's all. We have an additional group added. That becomes compound lipid. In simple lipid, we just had fatty acid and glycerol. But in the compound lipids, we have an additional group. That's all. And this additional group can be anything. One example I'll tell you. One example I'll give you. The one example is given in your NCERT is for phosphorus. Example is given in your NCERT is phosphorus. That is nothing but phospholipids. Phospholipids are basically a type of compound lipids. The example is lecithin. Example is given in NCERT is lecithin. Lecithin is the example. Lecithin is the example. Lecithin is a type of compound lipid. Compound lipid will have fatty acid, glycerol and additional. In additional here we have what? Additional in the case of lecithin we have a phosphorus group. That's all. That is your compound lipids. That is your compound lipids. Now, compound lipids can be three types: phospholipids, glycolipids, and sphingolipids. Sphingolipids not in your syllabus, glycolipids not in syllabus, only phospholipid is in your syllabus, that is lecithin. That is lecithin which we just discussed. That is lecithin which we just discussed. Done. So easy. That is what we just discussed. Lecithin we just discussed. That is a phospholipid. Now if you want one extra information, there is an extra information I will tell you. One type of glycolipid I will tell you. One type of glycolipid is called as galactocerebroside. Galactocerebroside is a type of glycolipid. Glycolipid, it is present in your brain. White matter, dark matter. That is, white matter of the brain is called as white matter because of whitish fatty appearance due to myelin. And the main lipid found in myelin is nothing but a glycolipid called as galactocerebroside. Galactocerebroside is a type of fatty lipid in the brain. That is because of white matter. Okay. Now, simple lipids done. Compound lipids done. Now, what is derived lipids, students? Is this in your syllabus? Do you think is there in your syllabus? Derived lipids? Yes, it is in your syllabus. Derived lipids, the example is given is cholesterol. Here, cholesterol is a type of derived lipid with 4 rings and aliphatic chain. Cholesterol is a tetracyclic in nature. 1, 2, 3, 4. Tetracyclic in nature. It is lipid derived from simple conjugate lipids, complex in structure. So example is given in your NCERT. Okay. Now, can we go through the NCERT? If we read every single point, if we have covered every single point now? Yes, let's do that. That is more important for clear understanding. See here now. See here. Lipids are generally water insoluble. I made you write down point. Point is written. They could be simple fatty acids. A fatty acid has a carboxylic group attached to R group. Fatty acids, we learned, right? It can be carboxylic acid plus an R group. The R group can be methyl, ethyl or higher number. Anything between 1 to 19. For example, palmitic acid is 16 carbon including carboxylic chain. Arachidonic acid is 20 carbon including the carboxylic chain, including some carboxylic atom. Fatty acids can be saturated, that is without double bond, only single bond, or unsaturated with only one or more CC double bonds. Another simple lipid is glycerol. We learned that. What is glycerol, students? Glycerol is basically an alcohol, right? Which is trihydroxypropane. Structure we drew. Many lipids have both glycerol and fatty acids. Both are there. Here, fatty acids are found esterified. We learned the entire reaction. Esterified with glycerol. They can be then monoglycerides, diglycerides, or triglycerides. Esterification. We learned esterification. We learned the esterification. Okay. Esterification. Then these are also called as fats and oils based on the melting points. Oils have a lower melting point, that is gingerly oil. We wrote it gingerly oil, and hence remain liquid at room temperature. Where I forgot. Liquid at room temperature should be somewhere. Hence remain oil in winter. Can differ fat from the following. Some lipids have phosphorus. Told you. Lipids can have fatty acids, glycerol, and some phosphorus and phosphorylated organic compounds in them. One example, lecithin. These are phospholipids. They are found in cell membrane. Lecithin is an example. Some tissues, especially in the neural tissue, galactocerebroside. I told you, galactocerebroside. It's given here. See, some tissues, especially in the neural system, have lipids with more complex structure. It's a type of glycolipid, galactocerebroside. Every single line, students, every single line. See here. Living organisms have number of carbon compounds in heterocyclic rings. Oh, that's all. Lipid is done. Lipid is done till here. Lipid. Students, do you remember? Can you see this small paragraph? We did it for such a long time so that the concept remains in your brain. Okay. If you just read this, you might not understand, but the concept is very important. Now from here, the DNA RNA starts, nucleic acid starts here. Tell me any doubt till now in today's class, right? Class is going very smooth. Principles of inheritance, Vedantu, it's a very easy chapter. Principles of inheritance is again a beautiful, easiest chapter. Trust me, every bio chapter is easy, students. If you have a right teacher who will teach you in an easy manner, every single chapter becomes easy, right? And here on the channel we have Gopika ma'am, who is an amazing zoology teacher, and botany, same. I am here. Our main goal here is to make the chapters easy for you so that you don't feel burdened by them. Alright, the only thing which we want from your side is to show us love and to solve questions, to just solve questions, just solve questions from your side. Any doubt you can always ask her. Any doubt you can always ask us. We are here to clear doubts. Okay, done, right? Done. See this question now, students, see this question. Read the following statements on lipids and find out the correct set of statements. Lecithin is found in plasma membrane, is a glycolipid. Why do you think I taught you that? Is it a glycolipid? Lecithin, is it a glycolipid or a phospholipid? Phospholipid. Saturated fatty acids possess one or more double bond. Do they have double bond? No. Saturated will have single bond. Gingerly oil has a low melting point, hence remain hot in the winter. Yes. Lipids are generally insoluble in water but soluble in some organic solvents. Yes. When fatty acid is esterified with glycerol, monoglycerides are formed. Yes. Which is the correct statements now? C, D, E. Just tell me now. See, that's what made you understand what is a glycolipid. We learned what is a glycolipid. It is a phospholipid, right? It is a phospholipid, not a glycolipid, friends. Not a glycolipid. It is a phospholipid. Lecithin. Phospholipid. So answer is going to be C, D, and E only. C, D, and E are correct answers because these two are wrong. Saturated will not have double bond. Only single bond will be there. Right? Look at this question. Look at this question now. Look at this question. Lipids having only single bond are called as unsaturated lipids. Lipid single bond is called saturated. So this is wrong. Lecithin is a phospholipid. Yes. Trihydroxypropylene is glycerol. Yes. Palmitic acid has 20 carbon. No. Palmitic acid has 16 carbon, not 20. Wrong statement. Arachidonic acid has 16 carbon. No. It is 20 carbon. This is 20. Choose the correct answer from the option given below. Which is correct? Easy now. You tell me now in the chat. Only one option is there. B and C. Only these two are correct. These are wrong, 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 wrong. So only when you know the chapter, it becomes very easy. Becomes easy. And this chapter is very easy. Okay. Now students, can we start with the next concept? It's going to be nucleic acids now. Nucleic acid. Again, very smooth journey. You do not have to worry about a single thing in this class. Very smooth journey. We'll go starting with nucleic acids now. We'll start with nucleic acids now. Tell me some green has in the chat, red has in the chat. I'll go drink some water and come. Now, nucleic acid. Nucleic acid. Let's start with nucleic acid. Let's start with nucleic acid. Yes. Students, I read your last comments. All of you have written beautiful comments and I loved it. And it motivates us. I told you already, right? Naina, Sebastian, Nikita, Ravindrani, Atul, Philo, Madhumita, Sebastian, all of you. Philo, Meghana, Manju. It gives us a lot of confidence and it shows that yes, whatever we teach here on the class is reaching to all of you. All of you are able to understand and this really good content for free on YouTube. And the only thing which we've written is the comments which we get, the likes and everything, that makes us really happy. And the only reason the comments are going to be helpful to us is going to be because YouTube promotes our video. I've told you before, YouTube will promote our video so that more students that yes, this is a good video. See, obviously tell me, before you watch a lecture, obviously you look at the comments. If the comments are good, you end up watching the video. If a new student is joining the RNA batch, he or she would not know how the teacher is. It is your duty to tell them, yes, this teacher has taught us, yes, this teacher has taught me this classes, and because of this teacher I am able to understand. When they read the comments, they will get to know, yes, this teacher is able to teach very well. So more students will join, more students will able to understand that, yes, I can join this, I can understand this sir, right? If this sir is able to make a chapter like biomolecules so easy, he can make any chapter easy, right? That is our goal here, right? Now let's start with nucleic acid. Now nucleic acid is again a very easy concept. All of you should know, first of all, nucleic acid is a macromolecule, macromolecule. It is a biomacromolecule, very large. Now tell me, will this be micromolecules? Will it be in retentate or filtrate? No. First simple concept. Will it be macromolecules? Will it be in retentate on top, or will it be on the bottom on filtrate? Filtrate or retentate? Tell me that. First you tell me that. Obviously, macromolecules size is more than 1000 atoms. It will be in retentate. Yes, it will be retentate. Okay. Now, nucleic acid is mainly made up of carbon, oxygen, phosphorus, nitrogen, and everything. Okay. Hydrogen is the main thing. Hydrogen. Now, I told you it is going to be retentate, so it is acid insoluble fraction. Acid insoluble fraction. Yes, acid insoluble fraction. Now, your nucleic acid is actually a polymer. It is actually a polymer. Nucleic acid is actually a polymer. Now, you might ask me, sir, what is a polymer of? What is a polymer of? That is very interesting. Nucleic acid is actually a polymer of nucleotides. When many nucleotides come together, we end up getting nucleic acid. And nucleic acid, the example is basically, simple example is going to be DNA, deoxyribonucleic acid, as well as ribonucleic acid. These two are the examples of nucleic acid. Examples of nucleic acid. Simple. Not nucleoside, nucleotide. Not nucleoside. Atubaru, it is going to be nucleoside, not nucleoside. Okay, nucleotides. Okay. Now, nucleotide has three main structures. A nucleotide will have three main structure. One is called as a phosphate sugar. That is the first one. Then it has a phosphate group. Okay, I am not able to write. Okay. Phosphate group, and the third one is a nitrogenous base. So there is pentose sugar, phosphate group, and nitrogenous base. Three things make up a nucleotide. Not nucleic acid. Nucleotide. So what is the difference between nucleoside and nucleotide? I'll come to that. So many, I'll tell you. I'm here, no? I'll tell you. Learn this first. A pentose sugar, nitrogenous base, a phosphoric acid or phosphate group. Three things are present in a nucleotide. One of them will be missing in nucleoside. Clues there. I'll tell you later on. Okay, when we come to that. It's right here. Okay. Now, what is the difference between, this is the major question which I always ask, what is the difference between DNA and RNA? What is the difference between DNA and RNA? I've always asked. Deoxyribonucleic acid or ribonucleic acid, you might say. But structurally, what is the difference? Structurally, how DNA and RNA are two different entities. How are they different? DNA and RNA. It's very simple answer. If you look at the structure of your DNA and RNA, the main difference is going to be the pentose sugar. The main difference between DNA and RNA is the pentose sugar. Pentose sugar is basically a 5-carbon monosaccharide. It is a 5-carbon monosaccharide. Central molecule in a nucleotide. See here. Central molecule in a nucleotide. Central molecule nucleotide. Now, in the case of your RNA, ribose sugar in RNA. In the case of DNA, deoxyribose sugar. Ribose sugar in RNA, ribonucleic acid. In the case of DNA, the pentose sugar is deoxyribonucleic acid. Deoxy sugar. Now, what is the difference between deoxy and ribose sugar? See, students, look at the structure of ribose. 5 carbon, OH, HOH, HOH, CH2OH. Simple ribose sugar. But in the case of deoxyribose sugar, deoxy, what is the meaning of deoxy? D means missing, oxy means oxygen, one oxygen is missing. D means missing, oxy means oxygen. So one oxygen is missing from the second carbon here. Only and only H is present here. Only H is present here. One oxygen is missing at second carbon. That is the difference between DNA and RNA when it comes to structures. One oxygen is missing, deoxy, oxygen is missing from the second position in the ribose sugar. Second position in the ribose sugar. Done. Very easy to understand. Now, nitrogenous bases. There are important again nitrogenous bases. There are totally 5 different nitrogen bases: adenine, guanine, cytosine. 3 are common. They present in both RNA and DNA. Thymine is present in DNA along with these 4. Uracil is present in the case of RNA along with the common ones. So ATGC in the case of DNA, AUGC in the case of RNA, AUGC in the case of RNA. This is in the case of DNA. In the case of DNA. Yes. This is very easy, right? Very easy. You would have learned this in the morning. In the morning you would have learned this. Right. Now, Gopika ma'am told me, sir, teach them structures today. Teach them structures. For example, what is the difference between purines and pyrimidines? Purines and pyrimidines. The difference in purines and pyrimidines lies in that structure, lies in their structure. Now, how I remember this is, all of you would have your own tricks, but I remember it as air is pure. That is A for adenine, A for adenine, P for purines, and air is pure. Air is made up of gases, and G is nothing but guanine. Air is pure. This is how I remember it. There might be easier method which you know, but this is how I remember it, how I've been remembering it throughout my life, all the way from class 12th. So this is easy for me. This is easy for me to remember. Now, difference between purines and pyrimidines is that in purines we have guanine and adenine. The only thing you need to note here is that guanine and adenine are double ring structures. Ring 1, we have double ring structures. There is a question, which of the following are double ring structures? They'll give you options: adenine. They'll give you adenine, cytosine, thymine and uracil. Your answer should be adenine double ring, guanine double ring. Purines are basically double ring structures. Purines are double ring structures. Purines. Okay. Now, what are pyrimidines? How do you remember this? Cut the pyramid. Cut the pyramid. CUT. Cut the pyramid. What is C? C is basically cytosine. U is nothing but uracil. And T is nothing but thymine. Cut the pyramid. Okay. Cut the pyramid. And all of the pyrimidines are single ring structure. Can you see structurally? Single ring. While you look at your purines, double ring structures. Don't get confused. Okay. So we have purines, adenine and guanine. Pyrimidines are 3 of them. Done. Cut the pyramid. That's it. Cut the pyramid. Clear? Understood? Yes. Gopika ma'am is in the chat. Gopika ma'am is on fire. Gopika ma'am is on fire. Oh, is a phoenix. Oh, that's a phoenix. That's a phoenix. Huh? Nice. This students, phoenix is a mythical bird which can be reborn. Beautiful concept of mythical creature. Okay. Now someone asked me, sir, what is a nucleoside? Simple students. In nucleotide we had nitrogenous base, phosphate, and we had a middle pentose sugar. In the case of nucleoside, basically the phosphate is missing. Phosphate is missing here. In the case of nucleoside, nucleotide minus phosphate is basically nucleoside. So we have the nitrogenous base as well as the sugar is there. Done. That's it. That's it, students. That's it. That's it. That is a nucleoside. Okay. So nucleoside is nitrogenous base plus pentose sugar. That's all. Nucleotide is phosphate plus sugar plus nitrogenous base. Now, how are they attached? This is very important. What is phosphodiester bond? That is ester bond formed between. How are the nucleotides attached? How are the nucleotides attached? The bond between nucleotides, the bond between nucleoside is nothing but ester bond. Ester bond here. Okay, so phosphodiester bond. Only one ester, but it's phosphodiester. Phosphodiester. Diester bond. Phosphodiester bond. Listen to me very carefully. Listen to me very carefully. This is one nucleotide here. Yes, sir. This is one nucleotide here. This is the other nucleotide on top. Yes, nucleotide 1, nucleotide 2. Now, the bond is between the third carbon. It says here somewhere. Where is it? Where did it go? Yeah, here. Students, are you able to see this? I'll erase this once again. Otherwise, it will become confusing. The bond here is between one phosphate, one entire phosphate, and 3 carbon, 1/3 carbon of the sugar. So bond is between sugar and phosphate. Sugar and phosphate. That is 3' to 5' diester bond. 3' to 5. I think you learned this today morning. Students, you would have learned this in the morning, right? Phosphodiester bond. In the chapter molecular basis of inheritance, same thing is given here. Same thing is given here. 3' to 5' bond here. A bond between the phosphate group of one nucleotide and hydroxyl group of sugar. Hydroxyl here. Hydroxyl group of one more here. That is 3' to 5' direction. Now, what is the difference between DNA and RNA? You would have learned already. DNA is double stranded. We'll just go over it because you learned today morning itself. And RNA is single stranded generally. Okay. Those represent sugar, which is bases thymine, cytosine, adenine, guanine. In RNA we have uracil is the separate one. Cytosine, adenine, guanine. More structure of it, entire structure, helical structure of DNA, Watson-Crick model, the base, pitch, everything you learn in molecular basis. Okay. Look at the structures. I think we'll open the NCERT, I guess. NCERT is better to read this. We'll open NCERT now, wait. Let's see here. Living organisms have a number of carbon compounds in which heterocyclic rings, okay, can be found. Some of these are nitrogenous bases, adenine, guanine, cytosine, uracil and thymine. When found attached to sugar, they are called as nucleoside. So nucleoside is what? Nucleoside is nothing but pentose sugar plus nitrogenous base. If a phosphate group is also found esterified to the sugar, then it's called a nucleotide. Adenosine, guanosine, thymidine, uridine and then are nucleosides. So always remember, for nucleoside it is INE. INE means nucleoside. If it is acid written, if acid is written, it is nucleotide. See, adenic acid, thymidic acid, guanic acid, uric acid and salicylic acid, they are nucleotide. Nucleotides are acidic. Side is nucleoside. Simple. Nucleic acids like DNA and RNA consist of nucleotides only. DNA and RNA functions as genetic material. See here. Sugars, carbohydrates, which I have not thought you will not go for there. Here, palmitic acid. Palmitic acid is here 16 carbon. Lecithin, phospholipid, which is a type of compound lipid. Here can you see? This is the glycerol part. Glycerol part is here. And then we have phospholipid here. So, sorry, glycerol part, fatty acid is here. Yes. And we have one phosphate attachment and triglyceride again. This is your lecithin structure. This is the lecithin structure. Phosphate attachment is here. Cholesterol, derived lipid. Triglycerides, 1, 2, 3. All three OH are with a fatty acid. Glycerol, fatty acids. So triglyceride. This is glycerol, trihydroxypropane, simple. If you substitute this OH with a fatty acid, it becomes triglycerol. Purines. Purines are double ring structures. Pyrimidines are single ring structures. Side is nucleoside. If it's an acid, it's going to be nucleotide. Acid means nucleotide. And students, with that we come towards the last part of today's lecture. With that we come towards the last part of today's lecture. Okay. So can we start? Can we start the last part of today's class? That is going to be metabolites. And I believe today till now also everything was very smooth and also you're understanding every single concept, right? So today's last concept is going to be metabolites. Last concept is going to be metabolites now. Second part we'll do. In second part we'll be doing proteins. Second part will be doing proteins. Second part will be doing the carbohydrates, enzyme reactions, as well as enzyme reaction. That will be again a 2-hour class. That also will be a 2-hour class, and that will happen tomorrow morning. Tomorrow morning, students, that class is going to be part 2. All of you don't sleep off. Tomorrow, part 2 at 12 p.m. Tomorrow. It's happening tomorrow 12 p.m. It's not like I'm going to make you, it's not I'm going to make you like wait for one more day or 3 days or 4 days or 5 days. No. We'll do it tomorrow only. So the entire continuity is maintained and you can say, yes sir, we finished the entire chapter. You get the satisfaction. You get the entire satisfaction you will obtain. Clear? So tomorrow 12 p.m. Don't forget that. If you have not liked the session, go like it for right now. Because second part is also very tricky. Especially the enzyme part, right? Especially the enzyme part. Students, all of you get confused. What is this Km value? Km value is there. What is the enzyme is increasing, enzyme is decreasing. Cofactor, coenzyme, right? All that we will be doing in tomorrow's class. But today's last part, metabolites. Last part, metabolites today. Okay? Now, what are metabolites? Students, what is metabolism? Metabolism is nothing but all the reactions happening inside the body. All the reaction happening inside the body is called as metabolism, which is anabolism plus catabolism. So in this metabolism, there is a substrate. There are certain metabolites. The metabolites which is involved in metabolism is your metabolites. We have primary metabolites, the substrate used in metabolism, secondary metabolites. Primary metabolites are directly involved in growth. Carbohydrates such as your glucose, which is used in glycolysis. Glycolysis is used in glycolysis. Lipids, proteins, nucleic acids, directly involved in growth. What are secondary metabolites? Secondary metabolites are mostly found in the case of plants. Mostly found in the case of plants, and main reason is defense purposes and stress purposes. Whenever the plant has to defend itself, it will do. Function will happen. Okay, function will happen. Now, there is a entire, the only thing you should remember here is the entire table. For example, this is the only table where they'll ask you questions from. Pigments, carotenoids, anthocyanin. Alkaloids, morphine and codeine. Codeine is used in the cough medicine, and there is morphine which is used in for patients and everything, right? Patients and everything. Terpenoids, monoterpenes, diterpenes, essential oils, grass oils, all this, essential body works, they'll be there. Toxins, aspirin and ricin. Ricin is used in the Breaking Bad series. Lectins is concaveolin A. Concaveolin is lectin, which is basically, concaveolin A is also what do I say? It promotes cell division. Promotes cell division. Okay, mutagen. No, promotes mutagen. Promotes cell division. Drugs. Vinblastine and curcumin. I'm saying the scientific name of turmeric. Curcumin, longer scientific name. Curcumin is the secondary metabolites. Vinblastine can cure cancer. It is found from your vinca rosa plant. Polymeric substances: rubber, gum, and cellulose. They are polymeric substances. See the question here. Which of the following is not a secondary metabolite? Lecithin. Lecithin is not a secondary metabolite. It is a phospholipid. Yes, done. See here. Match the following. Match the following. Go. The time starts now. I'll go drink some water and come. The time starts now. I'll go drink some water and come. Do this question. It's a very easy question. Do it. I'll drink some water and come. What is the answer now? Exactly, the one. What is the answer? Now, which of the following is not a secondary metabolite in plants? Vinblastine, curcumin, rubber, gum, morphine and codeine, amino acids and glucose. Not a secondary metabolites. Again, in plants. Amino acids and glucose. Amino acids and glucose are primary metabolites. They are primary metabolites. This is your homework question for today. And with that, class is done actually. This is a homework question for today. Homework question for today. Lecithin, a small molecule. This is a NEET 2024 question, so it's not an easy question. Molecular weight is compared to the living tissue is an example of. Don't tell the answer here. Don't tell the answer here. Tell the answer in the comments. I want everyone's comments. I'll be looking at it. Rakshita Reddy. Rakshita Reddy, Nikita, Pavitra, Jai, right? Herobrine, Sebastian. I will look at all the comments and let us know. Let me know in the comment section how was today's class. It was a very easy class. Biomolecules, half chapter is done. If you notice, Biomolecules, half chapter is done actually. And you will be able to solve all the PYQs. Go check out any PYQ from this part which I have taught today. See, primary metabolites, secondary metabolites. Here. Secondary metabolites, this table is very important. The only thing which is left right now, is when we go to bio macromolecules, we'll do it today, we'll do it tomorrow. Proteins we will do. Proteins. Then we have to do polysaccharides, that is basically carbohydrates. Very easy concept. Okay. Then nucleic acid, we did this, right? Nucleic acid, we have done this, nucleic acids. Nucleic acid is done. Structure of protein, which we'll do tomorrow morning. Then what are we left with? Last part is enzyme. Last part is, small part is enzyme. This is again easy part. And enzyme reaction and different types of enzyme reaction. What is happening here and everything. Tomorrow 2 hours the class will be over. With 2 hours the class will be done and dusted. That's it. Very easy concept. Okay. Very easy. Now students, let me show you something. If you have not liked the video, quickly smash the like button right now. Smash the like button right now. 1 second, there's some videos playing. Ad is playing. In our channel, they're showing me only ad. Friends, if you're not like this session, quickly like this question and homework question, please do it. So much of ads, sir. On our channel, they're showing me ad. Yes. Students, if you want to learn from Vedantu, all of you know Vedantu is doing super great right now, right? We are expanding to offline. If you're from Chennai, if you're from Tamil Nadu, if you're from Andhra Pradesh, we are opening so many offline centers there. And all of you are aware of all the teachers in Tamil Nadu and Telangana as well as Hyderabad, the teachers we have there. So if you're interested in offline learning from Vedantu, not from anywhere else, the same teachers which we have here, you can just go to this link right here and you can visit your nearest offline center right there. So go on right now, it's going to be completely free. Go visit it. If you like it, you can join. If you don't like it, you don't have to join. Right? So try giving it a visit once, and if you love Vedantu, just visit it once and make sure it happens. Okay? So with that being said, let me take off. I'll see you tomorrow morning at 12 p.m. with the part 2, and take care all of you. Bye bye.